I bet you didn't know our universe lets tiny particles break all the rules. The world of the very small, smaller than atoms, smaller than anything you can see, doesn't play by the same rules as the world we know. In fact, it's a place where the impossible seems to happen every day. Stop thinking of matter as just solid stuff, because in quantum land, things get wild. Down here, the building blocks of everything you know, your chair, your phone, even you, are made of particles that can behave in ways that seem to defy logic. Let's dive into the famous double-slit experiment. This experiment is one of the most mind-bending demonstrations in all of science, and it's been puzzling physicists for over a century. Imagine you have a particle gun, two slits, and a screen behind them. It sounds simple, right? You're just going to shoot tiny particles, like electrons or photons, at a barrier with two narrow openings, and see where they land on the screen behind. You fire one particle at a time through the slits. Each particle is so small it seems like it should only be able to go through one slit or the other, just like a marble rolling through a doorway. You'd think the particle would pick a slit, go straight through and hit the screen, right? That's what our everyday experience tells us. If you throw a baseball at a fence with two holes, it only goes through one. But here's the twist. When you don't watch, the particle acts like a wave. Instead of behaving like a tiny solid object, it spreads out, like a ripple on a pond, and seems to travel through both slits at once. It goes through both slits at the same time, and creates a pattern on the screen, like ripples from two pebbles tossed in a pond. The waves overlap, creating bright and dark bands, a pattern called interference. That's called an interference pattern. It's the signature of something acting like a wave, not a particle. And it shows up even if you send the particles through one at a time, as if each one is interfering with itself. But, if you watch closely to see which slit the particle goes through, it suddenly acts normal, like a tiny marble, and the interference disappears. The act of measuring, of observing, changes the outcome. So what's going on? Even the world's best scientists have scratched their heads over this. It's as if the universe only decides what the particle is doing when you look at it. In quantum physics, particles like electrons exist in a wave function, meaning they're in a superposition or multiple states at once until we look. According to the Copenhagen interpretation, the wave function describes all the possible places the particle could be, and only when we observe does it collapse into a single outcome. Scientifically, this means the result of a quantum measurement is determined probabilistically, and the act of observation causes the wave function to collapse into one of those possibilities. This idea is called superposition, and it's one of the weirdest, most powerful concepts in all of science. It means a particle can be here and there, up and down, all at once, until you check. Our act of observing changes the outcome. Just by looking, we force the universe to make a choice. It's as if reality itself is waiting for us to pay attention before it decides what to be. While the Copenhagen interpretation is the most well-known, other interpretations also exist, like the many worlds interpretation, which suggests all possible outcomes happen in separate parallel universes, or the pilot wave theory, which treats particles as guided by hidden variables. This isn't just science fiction. These quantum effects are real, and we can measure them in labs all over the world. Superposition powers quantum computers, inspires ideas like teleportation, and creates wild phenomena like entanglement. Quantum computers use superposition to process information in ways that would be impossible for ordinary computers, opening the door to solving problems we once thought unsolvable. Entanglement, another quantum phenomenon, links particles together so that what happens to one instantly affects the other, no matter how far apart they are. This spooky action at a distance, as Einstein called it, is being harnessed for ultra-secure communication and could one day revolutionize technology. In the quantum world, reality is stranger than fiction. The rules are so different, so counterintuitive, that they challenge our very understanding of what's possible. Who knows what mysteries we'll discover next? As we keep exploring, the quantum universe promises to reveal even more surprises, maybe even answers to questions we haven't thought to ask yet.